Lesson 6.4 is all about rectangles. So every fact we're going to learn today is all about rectangles. So first, the definition. A rectangle is a quadrilateral. So it has 4 sides with 4 right angles. Okay, we know the opposite sides are parallel and congruent. Okay, so opposite sides are parallel and congruent. So if you notice here, we have several theorems today. So if a parallelogram is a rectangle, then the diagonals are congruent. Okay, so that means the diagonals in a rectangle are the same length. All right, here's some more properties. So words, a rectangle is a quadrilateral with 4 right angles. We already have that. We know that opposite sides are congruent and parallel. We wrote that down up there, so that's our first property. Opposite angles are congruent. So opposite angles are congruent. We know that consecutive angles are supplementary. Okay, consecutive angles are supplementary, so you notice that's 180. Diagonals are congruent and they bisect each other. So not only are they the same length, all 4 little segments from that midpoint of each diagonal, or we could say that point of intersection, all 4 of those from the point of intersection to each vertex are the same length. And finally, all 4 angles are right angles. So they're all 90 degrees, which makes sense that opposite angles are congruent because they're all 90, and that consecutive angles are supplementary because 90 plus 90 is 180. All right, so we just have a lot of algebra here today. So our first example, it says quadrilateral RSTU is a rectangle. So they're telling us that. So we know all those facts we just learned are true. So if RT is equal to 6x plus 4, so that's the diagonal, and SU, the other diagonal, is 7x minus 4, we have to find x. So they gave us the length of each diagonal. Well, we know the diagonals are equal to each other, so we know that RT is equal to SU, so substitute in what we know. 6x plus 4 is equal to 7x minus 4, so I'm going to subtract 6x from both sides. I'm going to add 4 to both sides. So we get 8 is equal to x. And we are finished. So take a moment, try this your turn that looks a little weird, got cut off there. So pause the video and then come back. All right, so for this your turn, we found that x is equal to 5. All right, moving on to example 2. So quadrilateral LMNP is a rectangle. We have to find x. All right, I'm actually going to also make us find y here, just so you know. So to find x, since it's a rectangle, we know that all 4 angles are 90 degrees. So to find x, we could just say 5x plus 8 plus 3x plus 2, so that's our 2 angles, is equal to 90, because those 2 angles make up that 90-degree angle. So combine like terms, so we get 8x plus 10 is equal to 90. 8x is equal to 80, so x is equal to 10. So that one wasn't too bad. But now I said it doesn't ask us to find y, but I'm going to because you're probably going to have to know how to do this at some point. So we know the opposite sides are parallel. So if we have two parallel lines cut by a transversal, I know that this angle and this angle are congruent because they're alternate interior angles. So I'm going to set those two equal. So I'm going to do 3x plus 2 is equal to 6y plus 2. Now this is to find y. And you're probably looking and saying, well, I can't solve this because I have an x and a y. But remember, we found x, so now I can substitute this in. So 3 times 10 plus 2 equals 6y plus 2. So we get 32 equals 6y plus 2. Subtract 2, so I get 30 equals 6y. Divide both sides by 6. So y is equal to 5. Okay? All right, so take a moment here, and it just says to find x, so just find x. And I'm going to give you a hint. You're going to have to factor a little bit, so hopefully you remember some of that from algebra. If you get stuck, come back and I'll be doing it. All right, so we know that this angle and this angle are congruent because they are alternate interior angles. So I'm going to set them equal. So x squared plus 2 equals 14x minus 47. So since I have a squared term and a regular x term, I have to get everything to one side, like everything to one side. So I'm going to do x squared minus 14x minus 49 equals 0. Okay, so that's the first thing about factoring. You have to set it equal to 0. And now you may have factored a bunch of different ways, but they're all the same thing. It's just a different format. But the main thing we need to do is we need to find two numbers that add to give you that middle term, which is a negative 14. And then we have to find the same two numbers that give me the product of my first coefficient and my last coefficient. So 1 times negative 49 is negative 49. Okay, so I need the same two numbers. So what I do is say, okay, well, what are all my factors of 49? 1 and 49, 7 and 7. This one doesn't have too many. And if you look, 7 plus 7 is 14, but I need them to be negative. And I'm sorry, this 49 is a positive 49. Good thing I noticed that. So in order to get a negative 14, both of my 7s have to be negative. So negative 7, negative 7. Remember, they all have to be the same. So let's see. Negative 7 plus negative 7 is negative 14. Negative 7 times negative 7 is positive 49. So voila, we found our two numbers. Now, since this coefficient is a 1, which is all you guys had to know how to do back in Algebra 2, is we can go right to our answer. So our answer is going to look like this. It's going to be x and an x, and the two numbers we found go in both of those places. So since that's a negative 7, that becomes x minus 7. Took care of that one. Since this one is a negative 7, that becomes x minus 7. That's the hard part. The easy part is solving this. So now you just set each of them equal to 0. And then solve. So we get x equals 7 and x equals 7. So guess what x is equal to? 7. Okay, you can get two different answers though, but in this case we just got one of the same. Now I can show you how to find y. I know this problem doesn't ask for it. I'm going to go ahead and delete this so we have some room. But to find y, it's not too bad. So since all of the diagonals bisect each other, I know that this segment is equal to that segment, which means this is now an isosceles triangle, and my two base angles are congruent, so those two. So now that we know that x is 7, I'm going to substitute that back in. So 14 times 7 minus 47. So this angle is 51 degrees, which means that one's 51 degrees. I got a different color here, something that's sort of bright. But we know this whole angle is 90. So we know that 51 plus 4y minus 5 is equal to 90. So we can do 51 minus 5, and we're going to get 46. So 4y plus 46 is equal to 90. Subtract 46 from both sides. So 4y is equal to 44, and then y is going to equal 11. So just in case on your practice work you need to find something like that, I wanted to go ahead and go over it. Okay, all right, we have two more, and these aren't, there's not too much math involved. So the theorem says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, so it says Kyle is building a barn for his horses. He measures the diagonals of the door opening to make sure they bisect each other and are congruent. How does he know that the measure of each corner is 90 degrees? So the reason for this one, if he measured the diagonals, so he measured the diagonals of the door, and they bisect and are congruent. If they do that, then we know it's a rectangle. Okay, so we can say, we know it's a rectangle because the diagonals are congruent and bisect each other. Okay, and then we can say a rectangle, whoops, don't want one word, has 90-degree angles. So this first part is saying how we know it's a rectangle, and the second part says, well, if we know it's a rectangle, then we know it has 90-degree angles, okay? So take a moment, try the your turn, and then come back. Where did it go? Oh my goodness. Here we go. All right, so hopefully that makes sense if you read the